Now, welcome to my channel. You can be given a question like this. You can be told to differentiate. You can be told show that the differential equation of this one is equals to 0. Satisfied when you've been given y is equals to x multiplied by exponential 2x. By using successive differential, we know that we are going to do our first differential with respect dy with respect to dx, and then we are going to move to our second differential. After carrying out all this differential, we are going to substitute our first differential with respect here and our second differential with this one to satisfy that whatever we have on this side is equals to 0. So we have y is equals to x exponential 2x. When you look at this is just an when we want to differentiate x and exponential 2x, this is just an application of product rule. And by the product rule, we understand that dy with respect to dx will be equals to u dv with respect to dx, we add to v du with respect to dx. Our term of u is equals to this one. This is our term of u, and our term of v is equals to this. So we are going to have u will be equals to x, and our v will be equals to exponential to 2x. Our differential with respect to du will be du with respect to dx will be equals to 1. And our differential with respect to v, we are going to have dv with respect to dx will be equals to 2 exponential 2x. Let us now substitute what we have here on the formula, and by doing that we are going to have u will be x, dv with respect to dx will be 2 exponential 2x. We come and add 2, our v will be exponential 2x, and our d with respect to dx will be equals to 1. When we simplify what we have here, we can have 2x exponential 2x, we add to exponential 2x, and this is our answer with respect to dy with respect to dx. This is our answer. Since we were doing a successive differential, now we are going to move to our second step, whereby we know that dy squared with respect to dx squared will be equals to what? Now let us do a differential on this equation now. And when you check on this one, x multiplied by exponential 2x, here we are going to apply the product rule. And when you look at this one, is equals to what we were having initially. To mean that when you carry out the differential on this, it's going to give you the whole of this one. So here we are going to have 2 into the differential of the whole of this is equals to this one, 2 x exponential 2x, we add to exponential 2x. When you do the differential of these two, you will have what we have here. And now let us move to here. We are going to have add to the differential of this one to exponential to x. Let us now simplify what we have here. We are going to have 4x exponential to x. We add to 2 exponential to x. And lastly, we add this one to 2 exponential to x. And here you can have 4 exponential to x. We add to 4 exponential to x. So this is now our second differential. Let us substitute what we have here with respect to this. And because here, when we come and check here, it is said that we show that the differential of this differential, that differential, and a term of y, when we replace them with dy, when we replace them with dy squared and dx squared, dy and dx with and y, it should be giving us a 0. Now let us have that replacement. Here we are going to have dy squared with respect to this one will be 4x exponential to, we add to 4 exponential to x, and here we are going to subtract from 4 into this one. When we take this one, here we are going to have the differential of dy with respect to dx was equals to 2x exponential to, we add to exponential to x, and lastly we are going to have 4 multiplied by 4 multiplied by x exponential to x. Here everything should be equals to 0. Let us now open the bracket. Here we are going to have 4x exponential to x plus 4 exponential to x minus, here we are going to have 8x exponential to x, and here we are going to have subtraction of 4 exponential to x. We add to 4 exponential to x, everything should be equals to 0. Let us collect the like terms together. Here we are going to have 4 exponential x exponential to x. We subtract from 8 exponential to x, and lastly we add to 4x exponential to x. Subtract from 4 exponential to x, and we add to 4 exponential to x, everything will be equals to 0. So here we are going to have this one and this one. This one is going to be cancelling out to be 0, and this one is a negative exponential to x, positive, this one will be cancelling out to be 0. So here 0 is equals to to 0. To mean that we've satisfied when y is equal to this one, by replacing in this equation, we are going to have 0 is equals to 0.